and we're going to be doing VRV4 fault finding and troubleshooting this afternoon out of Cape Town and presenting for Daikon Service Academy, South Africa. If you could just watch the house rules that are on there, and so let's get started. Okay, so we're going to look at some level 3 type service training. This is training that's been put together by Europe, and it's designed to assist service engineers in their course of duty as they work on VRV4 products. Okay, so the first thing we look at is some error-based troubleshooting. Now, as I said earlier on, we're going to move at quite a pace through the first session. It's designed more to give you an idea of where to go to look for troubleshooting information, and then we're going to look at some actual practical testing things later in the course, which I'll spend a bit more time around, and I think that's where generally most of the questions are going to come from. So, error-based troubleshooting. We're going to look at how to retrieve these error codes from a unit, where to find information about an error, okay, and how to reset an error. Okay, all right, so how to retrieve error codes. And of course, some of you will be very, very familiar with this chart. I mean, it's been on the internet and for many years, and basically it says, does the damn thing work? And it says, then don't mess with it. Okay, and if you don't mess with it, then you won't have a problem. But of course, if you did mess with it, I'm not going to repeat that. Okay, does anyone know? Yes or no? No, they don't. Then you can hide it. Then you don't have a problem anymore. Okay, it's a bit of humor in there, and I think we can all relate to it. Okay, we all know what a typical day as a technician is like. Okay? Generally, in terms of problem solving, okay, just change that there. We always start off with a problem. That's why we go to site as a service engineer or service technicians, okay, to solve a problem. In order to do that, we need to analyze that problem. We need to collect information, first of all, about the unit that we're working on, okay, and then the type of problem that we have, okay, and then from there, we will be able to plan and put together a solution, okay. Where do we retrieve error codes from? Error codes are retrieved from the remote controller. These can be the BRC type, okay, or the new Madorka controllers. We can also get them from the outdoor PC boards. And the scope of this training today will revolve around these areas, okay. In the past, Daikon had a MALF code, okay. It was a list of errors, and it was put onto a chart. This was available as a printed form, but it's also available for download from the internet. If you just do a simple search, Daikon, MALF, you will find that this will come up as a PDF document. There's a couple of extra pages that go with it, and it's very, very useful to have printed or as a copy on your smartphone. One of the things that you need to understand about this MALF code chart is that it's systematically set out that error codes can be located for the indoor unit. Remember, A and C errors will always point you to the indoor unit, okay? Errors E, F, H, J, L, and P will send you to the outdoor unit, and then we've got some system errors as well. The errors down the bottom here don't pertain to the equipment that we're talking about today. Okay, so generally, if you see errors A and C, you will know that you'll be heading towards the indoor unit to start your diagnosis. And then the errors that I mentioned in the second part there, outdoor, they're going to send you there. System errors can be intercommunication between the devices and the units. So there you may be moving around between indoor and outdoor. Okay. If I could just ask again, if you could just mute your microphones and turn your cameras off. Thank you. All right, so that's the MALF code chart, and it's been around with us for years. Right. Hi, could we just mute our mics, please? All right. our older type controllers, the BRC-D and BRC-E type controllers. Many of you are familiar with these. Okay, and these can be used for retrieving error codes as well. Okay. Okay, and then we've got our new BRC-1H controllers, the Mordauka type controller. And as you can see with these as well, they will also give you an error code, and you'll need to use the buttons on these controllers, the naught, the negative, and the plus, to get into the different menus to retrieve. Okay, and these are explained in their service manuals or in the manuals for these controllers as well. Okay. From VRV4 onwards, we have found that locating errors has become easier from the condensing unit, as the display in the condensing unit changed from the old LEDs through to a 3-segment display with less buttons underneath it to push. Okay, so it became a lot easier. This is a very easy way of retrieving error codes. Okay, in case there is no instant malfunction code, and this does happen, sometimes you get to a system and the client has complained, said, oh, this unit keeps on misperforming, okay, and you need to find out what was possibly happening. The error code may have reset itself. What you can do, okay, is you can use the last forced off, and it'll give you the last 3 forced off conditions using the monitor mode 1, and then using 17, 18, and 19 to read off those error codes. Okay, it's a very important thing to do, to remember that it keeps those in the history. It's very good to actually do those on a service basis when you're servicing equipment, to see if there's any problems that are starting to show their head. Okay, and then you can also use modes 1, 23 through to 25 to check the last retry. And remember, with error codes in VRV, a lot of times the unit will not kick out an error code immediately. It will try a number of retries, and if it's not successful, only then will it deliver an error code to you. Okay, so where to find information about the error code? All right. You can go onto the internet, okay, and if you look for the following address, which is my.daikon.eu, okay, you will need to be registered on this site over here. So if you speak to your local salespeople, they can arrange for that. Okay. And once you're registered, you'll have everything set up that you can then enter onto the site. Okay, there's a basic registration on there. Okay, and if you haven't been registered and you are dealing a lot with Daikon equipment, I would suggest that you become familiar with the site. Okay, support on error codes can be found using different documentation. Okay, and all of this documentation can be downloaded from the site. Okay, we can also use the service manual, also available, and that's available as a PDF and an online HTML document. Okay, so there is what the site would look like. You would type the model number of the unit in there, okay, and it would then take you through to a page with all the documentation that you would need. And that documentation is not just for service, you can also get your data manuals and things like that off of there. Okay, and there's the door. Okay, and it would open up and make it that easy. Of course, with every unit that we sell, we also supply an installer user reference guide. Okay, that's wrapped up in plastic with the commissioning charge sheets in there as well. Often we get to site and find this hasn't been opened, and I would recommend that you read through this manual, as it lays out everything that you need to know about the installation. That would be everything from selecting the pipes to the correct armor flex, making sure that that's the correct wall thickness. We see a lot of installations nowadays where guys are attempting to use 1/4-inch wall armor flex, and even by local legislation, that is not allowed. Okay, and it's not allowed in the manual either. I'm just going to recommend that, because I get asked this question often, I'm going to just put it out there, that by South African legislation, we are only allowed a 5% decrease or increase, depending on the mode, in temperature difference between the condenser and the indoor unit. Okay, so just keep that in mind when you're selecting Armaflex. All right. Okay, this gives you an idea of what the fault finding or the troubleshooting side of that manual looks like. Okay, and how it's laid out. And it has some of the system errors in there. Using the service manual contains the most advanced level of troubleshooting info and guidelines. Okay, this is a very, very important manual to download. And I would suggest that if you're going to site to carry out fault finding, that you download this manual and take it with you. Nowadays, most guys are working on tablets or smartphones, but it does help as well if you're working on a lot of VRV equipment to print a copy and keep that with you, because whenever you do something, you tend to want to write in the margins the things that you might have found, and for future reference, this does help. Okay, so inside that manual, it also gives you a rundown of error codes, and that's generally what it looks like from the front page. All right, inside the manual on the PDF mode, okay, you also have active links. So as you read about a possible error and cause, it also has active links to take you to pages with more information. And you'll see the pages are laid out to help you identify components in a very simple manner, where you could go from a wiring diagram to an overview schematic of where everything is placed to a diagram that will then show you where it actually is on the machine. Okay, so it makes it very easy for locating components, and you should be able to locate them pretty simple with that. Okay, how to reset an error. Okay, some errors are resettable via the indoor controller. Some errors are resettable by power reset on the outdoor unit, and some errors are auto resettable once the error condition has been resolved. Okay, so that's important to know, and how to go about resetting those. And basically, yeah, so in the old days, you'll remember with VRV3, E3 errors had to be reset from the condenser through a number of steps. Okay, you'll find with VRV4 and on, that now is not necessary, although E3 errors can also be linked not only to head pressure but to voltage fluctuations, which we are all very familiar with load shedding, and that can also be a cause, just to keep in mind on there. Okay. VRV4, product service training, troubleshooting and repair. Let's have a quick overview of service tools. Okay, I'm not going to go through all the service tools. Okay, I'm going to look at some of those that are available to our dealers. All right, and basically we're looking at the D checker, the mobile monitoring tool, okay, and the inverter analyzer. Some of you guys will be familiar with this, and then some of this will be new to you. All right. As with our very advanced service tools, they tend to give a lot of information. And in order to be able to get to the bottom of this information, it's very important that you learn to read them in conjunction, okay, with a service manual, and then also contact us or send us the recordings, and we can go over it together with you, or send you a report on a recording on what we can analyze from it as well. Okay, we have a lot of guys, and some of the descriptions in here, you must remember, are translated from other languages, and they can be a bit confusing. So just as you read something, you just need to take into mind that what might be what they call a suction temperature is actually a return air sensor, say on an indoor unit. Okay, it's not actually a gas pipe sensor. All right, so that's just something to keep in mind as well. Okay, and you can see here, this is just one part of the information. Okay, from a condenser 3. All right, and yeah, and you can see that over there is quite something to try and get through. It's an overview of the tools. Okay, so the two tools on the left over here are the service checkers type 3 and 4. Currently, these are not available to dealers. Okay, and but what is available is the D checker, the mobile monitoring tool, which is a Bluetooth device, and then the inverter analyzer for testing of inverter PC boards. So let's have a look quickly at these. In terms of the D checker, the equipment is available for purchase from us. You'd require a laptop to plug it into. Okay, and what this little slideshow is taking you through is basically using the Daikon site to be able to download the D-Checker software. Okay. There's the D-Checker. That's basically what it looks like. This is the way it connects. It connects to your laptop through a little dongle and then onto the X27A port of the main PC board, the A1 PC board, or what we also call the control PC board. Okay, and it's on a 5-pin connector. Okay, and then obviously to get the software, you would then go up on the site and you can download it. If you're having problems downloading the software, if you have purchased this, let us know. We can always download it for you, and then we can probably do a WeTransfer or something and get it through to you. All right, it's always important as well to make sure that you're working with the most up-to-date software when using these tools, as the software is updated periodically on new releases and on improvements as well. Okay. That's basically what that little video over there is showing us. Okay, so I'm going to move on from there. The next tool, which is a tool that's become popular, is the mobile monitoring tool. I think everybody wants something that talks to their cell phone these days, and this is the tool that does that. Also utilizing the X27A plug. This tool will plug into that, and then you will need to link this up through your Bluetooth, okay, onto your phone. Again, what we've done with the guys when they've purchased this is some of the guys have brought it into our office, and we've done a little short training session with them on the equipment that we've already got installed just to get them started. Okay, all right, and it's also gives basically the same information that the D-Checker and the Service Checker gives. You can also make a recording with it, and it's a very, very nice tool for analyzing problems. Now remember, with all of these analyzing tools, okay, these are not crystal balls. Okay, a lot of people say, come plug a device in and tell us what's wrong with the machine. And the type of thing that they're asking us to do is to try and identify a component that's faulty. And sometimes you actually need to go back to old first principle fault finding first, okay, and to ensure that that everything is powered up before you start plugging things into it and expecting it to deliver a miraculous solution to a problem. Okay, these are just tools that work in conjunction with everything else that we should know as technicians to help us source the information and analyze it and then get to a better solution. Okay, so the manual release notes for this are also on the business portal. Okay, and here you can search for them by mobile monitoring tool. All right, basically that's it over there. Then you will need to download the app, of course, and because I said it links up with your cell phone, you will need to download the app, and the app logo looks something like that. It's the Daikon with the blue and black triangle, and underneath it says monitoring tool. You'll need to download that. It's downloadable from Apple Store and from the Google Play Store as well, so it's compatible for both of those platforms. Okay, and so you go through, do your search. And then you would install the app. Okay, Inverter Analyzer. Okay, this over here works on the principle of measuring the output from the inverter PC board for the compressors. Okay, and basically you'll see in a later stage this afternoon, I'm going to discuss the layout of that PC board, and then you will see basically how this operates. It's got 6 LEDs, and you unplug the compressor wires, you plug the compressor wires onto this, and then you put the VRV into mode 28. Okay, mode 228, should I say, and that over there will activate the transistor check mode, right? And that will then start the lights flashing. If the lights don't flash, it means that there's no output from the board, or that the inverter PC board is not getting the signal from the control board. The lights should flash evenly, all 6 of them. Okay, if you find that some of them aren't flashing or not flashing at all, they would indicate that the outputs from the inverter PC board are damaged, and that PC board would also need to be replaced. Now, I know that we're talking about VRV4 this afternoon, but something that we pick up from time to time is where the Inverter Analyzer is used on the old VRV3 PC boards, and they test fine, but when connected to a compressor, the PC board still gives an L5 alarm. And something just to remember, that PC boards also have a usable life, okay? And when some of these PC boards, I think they're rated out at about 40,000 hours, when they start getting to that sort of usage in their life, they may need to be replaced. As with all things, components fatigue, and although it gives a clear on the low output, when you put a load on it, sometimes that PC board is damaged. So just keep that in mind if you are working on VRV3, okay, and you're getting L5 errors. Very often they may be because the PC board has actually reached the end and components have become fatigued on it. Okay. And again, there is also an instructional video available on site, on the Daikon site for the use of that. But we also do have a Daikon South African YouTube channel. Okay. And that will also have that video on it in the future. Okay. All right. Before we go on to component check, I'm going to ask you guys, are there any questions?
Just want to find out about the pricing on that D-Checker and Inverter Analyzer.
Okay, I haven't got pricing with me. Okay, the point of this afternoon is not really to talk about the pricing of it, but that is available from our sales teams. Okay, if you do drop us an email, then we can actually get the pricing through to you, and okay. that may basically just talk to a salesperson, advise the pricing that's relevant to you.
Okay, 100%. Thanks.
Okay. Okay. Any other questions there? I'm actually not seeing my chat box at the moment, so I do apologize for that for some reason. Okay. All right, I'll pick that up at the end then with the chat box. Okay, component check. Sorry, could I just get a sound check there? Can you still hear me?
All working.
Great, thank you very much. Okay, thank you.
Yep, I can hear you.
Yeah, thanks. Okay, right, should we continue?
Yes.
Okay, once again, if everybody could just turn off their microphones, okay, and their cameras, and we're going to continue with the most important part of this afternoon. Okay, and I think this is where a lot of the questions are going to come from. We're going to go through things. It's going to be a couple of things that you'll see are repeated, but generally the idea is just to get you guys moving in a direction to help you be able to do some component checks, which is very important. All right, so component checks. First of all, where to find information to check the components. Some of that we've already covered already. How to check a component, in other words, a thermistor, through the service manual. Okay,
there's no sound. Sound is working, might be your signal.
All right, okay, thanks very much. Okay, so how to check a component, the thermistor, through the service manual, where to find information on location of the component. Now, VRV is a very complex unit, and if you stand back and look at it, when the panels are off, it can be quite confusing to try and get your mind around all the expansion valves and thermistors and the PC boards, and obviously compressors and everything that are inside there, especially when you're looking around a junction of piping. Okay, so it's very important to use the service manuals, as these have diagrams in them and pictures to show you where to locate the various components. All right, so empirical troubleshooting is based on observation and measuring phenomena and derives knowledge from actual experience rather than from theory and belief. Okay, so it requires, and most service technicians will try to carry out some form of empirical troubleshooting, okay, but it requires a method, okay, and some information collection. Okay, that will be through measuring phenomenon, and then applying that against knowledge, okay, and your actual experience in order to get to a solution. So there's a problem. Okay, this is not to do with VRV. This is, but just to give you an idea of what could happen. Water in a connection on some chiller controllers was found to cause a short circuit. Okay, you can see the damage caused. The end result, 9 corral controllers, 16 pressure transmitters, and 8 expansion valve drivers before somebody actually got to the bottom of the problem the correct way. Okay, the solution, all you had to do was replace the connector. Okay, so parts replacing, you can see, can be very expensive if you don't get to the root cause. So there's just a small example of moving from problem to correct troubleshooting to a solution that actually works. And I think in today's environment, one of the things that we're trying to do, and especially through training like this, is to move people away from wanting to just do parts replacement. If you've got a faulty PC board, the type of thing you need to do is check the plugs and other items plugged onto that PC board before you start up the next one. Because a faulty fan motor can blow a very expensive PC board if you haven't identified that the fan motor blew the first one. Okay, so it's very important to do fault finding and not parts replacement. Okay, what can we expect from this? Well, we'll learn to find information about how to check a component. We'll learn how to locate the component in the unit, and we'll learn how to check and measure a component. And we're going to look at some of the main components as we move through the next section. Where to find information about it, we've already discussed. You can get this information from the mydaikon.eu. We can also use the Daikon Service App. Some of you guys are familiar with it, and if you aren't, by the end of this afternoon, I can guarantee you're going to be downloading it. Okay, and then also using the service manual. And the service manual is your best friend. I can tell you now that there's a multitude of information inside the service manual, and it's well worth the read if you are working on equipment and having on you before you actually leave for site. It's also a useful thing in planning if you've already had a phone call where somebody says, oh, my controller's flashing an E3 alarm. You can get the manual out and say, oh, these might be the items that I might need to take with me, or I need to get my head around. This is how I'm going to tackle the problem when I get to site. All right, so we've gone over the manual. The one that is most used by technicians, and that includes the Daikon service staff, is the Daikon Service App, the UK version. Okay, the symbol looks like that over there. It's a little gear wheel with the Daikon triangle. Okay, and you can download it. It is also Apple and Android based. All right, so that's what you're looking for. You search for it on the internet. Okay, you will install the application. Once you've installed it, open the application. You'll see it gives you 3 equipment pillars that you can look at: VRV, Altherma, and Split and Sky Air. We're talking about VRV today, so you will touch the VRV screen, and that will open up. Okay, something that looks like that. Okay, and this will get you going. So basically, you can see you can use it to do a fan coil and BS box check. Okay, so that would be counting up the number of fan coils on a unit or BS boxes. You can even do a VRV charge calculation, okay, on there. And you can also use it as basically for VRV 3 and 4. Okay, and it's got some advanced outdoor settings and a few other things. And this page actually scrolls down, so it's got quite a bit of information on it. Okay, very, very useful app to use. On the bottom of the app, you will see that it's got a system. This will take you back to the 3 options that you had in the beginning. It's also got one for entering the error code, one for checking pressure transducers, and one for checking thermistors. And we're going to quickly move through how to use the app to do that. Okay, so we've got advanced outdoor settings. By touching on that, okay, this will bring up items like refrigerant recovery mode. Very, very important mode to know about if you're recovering refrigerant or you need to pull a vacuum on a VRV system. Because of the complex piping in a VRV system, it is not possible to just connect your gauge hoses onto the service valves and pull a vacuum. You need to open all the solenoid valves and expansion devices in the unit in order to have the entire system open to the vacuum pump and to make sure that you've got no air locked up in pockets of piping. This is critically important, especially as we move into an era of R32 gas. Okay, but we all know that even air and any other the other refrigerants has a negative influence on its performance, on the refrigerant's performance. Okay, so you'll see that there's a couple of items listed down there. These are all very, very important in terms that they help you with fault finding. Okay, so you can move from there. Okay, we could do an inverter transistor check, which we were talking just now, the inverter analyzer. This will then show you how to set up the unit to do the transistor check mode. Okay, and it does it. Okay. Okay. It gives you the option of looking at either the old VRV3 or VRV4. Okay, and then taking you through a step-by-step process as you swipe the screen. Okay, it will tell you, it will give you instructions to carry out and then show you what the controller on the unit should look like, making it very, very simple to use in a very simple animated way. Okay, and then basically how to select that mode. Okay, and then to activate and deactivate and go back. Okay, so this is just a guide over here. Once you've played with the app, you will actually see just how simple it is to use. This is an overview that we've tried to put together to use this. All right. Okay, so here's a description. Remember, I said to you, the bottom 4 devices or keys are often overlooked. And these are the system, the error code, and this is what we're looking at now. So when you touch the error code, you'll get a screen like this, and into that you then type in the error code. If you get an error code that's got the adjacent number with it, please do not put in the dash. Just type it in as U401 or U403. Okay, otherwise it's going to tell you that it doesn't recognize that error. Just leave the dash out. Okay, and basically this will then come up and tell you what the description of the fault is, and it'll give you some information of where you need to start looking. Now, I know that Android and Apple have some different setups. I believe that some more recent Android devices give a bit more in-depth, but on the Apple phones, you will find that there are additional tabs on here that will actually take you to and show you what you need to do to fault find. Okay, so that's basically what you would do. Enter the error code, and it will then give you a description. Okay, then use the detail of the fault below to help you go through the different things that need to be checked. Thermistor check from the app, also very, very simple. Okay, what you do is you would then, first of all, you would have identified your thermistor and unplugged it. Okay, you will then measure the air temperature around that thermistor, for instance. Okay, and when you enter that, it will then tell you what the resistance should be. Now, just to take note, we're going to discuss this just now, but you'll notice that there are 2 different values. Okay, there are thermistors for the heat exchangers and for air. Okay, that will give you a value like that, and the discharge thermistor on the discharge pipe above the compressor gives a different reading. And when you see the chart just now, you'll understand why there's 2 different values. Okay, that they've run with on there. Okay, when they've put this together. So that's basically how to use the temperature analysis for a thermistor. All right, and you'll select that, put it in, and there it'll give you a resistance value. It's very, very good to check as well as a service item, because you can then also check whether thermistors are out of calibration or not. And it's also, remember that with a system that's complex, that's using electronic input and output, when something is out of calibration, the system will perform abnormally to that out of calibration. So it is a service item to look at replacing, okay, if those thermistors are out of calibration. I can't tell you how often they go out, but I can tell you that I recently did an analysis of some VRV3 equipment that is probably close on about 15 years. And the number of the units we're actually replacing thermistors on them because they were out of calibration by at least 3 degrees. Okay, so just something to keep in mind from a service aspect. And remember that these things all add to the bottom line of your company. When you can go to somebody and say, look guys, we've analyzed, we can see these thermistors, they're out of calibration, we can improve the performance of the machine by putting new thermistors in. This helps you in your business as well. Okay, then so then there's also the discharge one that I discussed just now, but we'll see later. I've got a more in-depth analysis of this as well. Right, there's also, if you look to the right-hand side of the temperature input, there's also a little information button, and by tapping on that, the information button will open up and actually show you what the plug looks like and where to measure. Right, because to measure this, you need a multimeter. Okay, do not use your buzzer check. It doesn't have the impedance on it to measure thermistors. So you need to use your straightforward resistance ohm meter on there. Okay, and it'll give you a value in kilo ohms. Okay. Right, then the next one we're going to look at is the pressure transducers and how they work. Okay. And pressure transducer, basically just an overview. If you're not familiar with them, they convert pressure to a voltage signal so that a PC board can read it. Okay, now in order to do that, they must put a supply voltage onto the transducer, and the transducer will then send back a varying voltage that relates to pressure. And on the app, it gives you two options. Okay, you select it first of all from the bottom. Okay, you will then type in a pressure. Okay, this one over here is doing pressure to voltage. Okay, and it will then tell you what the voltage should be. Now remember, you need to know that first of all, we have a high pressure and a low pressure transducer, and they both have different characteristics. So you need to make sure that you're reading off of the correct side of the app when you're doing this. Okay. All right. It's also got an information button on it. Okay. By tapping that information button, it then takes you through to a photograph to show you what the plugs look like. Okay. And each of them are wired differently. So you'll see the low pressure uses pins 2, 3, and 4, while the high pressure uses pins 1, 3, and 4. Okay, so they're not interchangeable. If you plug them on the wrong plugs, obviously you can match them by color, but if you happen to get them in the wrong place, the unit will start giving you JA and JC alarms. Okay, so just be very, very careful of that. But also note that you need to know these plugs because you're going to need to carry out the voltage test. Okay, and you can see here that if you measure between 1 and 3, okay, this is where you're going to get your varying voltage. The power supply onto the device is through 3 and 4. Okay, so there's just a basic diagram, and that's given to you there as well. All right. Okay, we've also got some replacement dip switch settings. Now remember, when replacing control boards, you need to select the inverter the inverter capacity, the unit capacity, shall I say, and that needs to be done through the dip switches. If you don't do that, when you power up, the unit will give you a PJ alarm. Okay. Also remember that on replacing a control board, selecting the correct inverter capacity, unit capacity, you will then need to put the unit through a new test run, okay, in order for it to do a learning cycle on that. Okay. Then back to the system, there's a refrigeration comparator on there as well, which will also help you so that you can select a refrigerant and you can determine pressure, temperature characteristics. Okay. There. Right. Okay, and then there's also frequently asked questions. Okay, now as I do each update of this app, some of these you'll see some more questions being added to it. Okay, and it'll tell you what should I have on the F1, F2 connections for connecting. So it's looking at a voltage, and it will tell you that when you have that, you should be looking for a constant 16 volts DC. Okay, so there's just a little thing where the guys often phone us and they'll say, what voltage should I be measuring? Yeah, the app will actually tell you what that voltage is. Okay, right, so then of course the service manual. Okay, and like I said, the service manual has some active links in it. So very often all you've got to do when you're using it on a computer is to hover over a particular item, click on it, and it will take you straight to that page and you'll give you a page layout that may have other links on it that will take you to further fault finding. So the first thing as well is always to identify the component, find out where it is, and then look at how you're going to fault find that particular component. Right, so how to check a component, and this is now where we're going to go and spend a little bit of time this afternoon. Okay. First of all, we need to know the name of the thermistor, the wiring symbol, which PC board it's connected to, which connector it is on, okay, which pins, and what thermistor type it is. Okay, so remember we saw just now that there are two types of thermistors that you'll find within a VRV system. This chart inside the service manual will direct you in that area of what to do. It will also give you a small temperature resistance chart. Okay, and that will also help you if you don't have the app. But most guys today are looking for app-based things that can help them resolve that type of thing quickly. Okay. You'll also see that it will then direct you to a schematic view, okay, of the piping with all the thermistors marked on it. Okay, you will also see a wiring diagram with the thermistors marked on there as well. So you can now relate these thermistors back to the wiring diagram. There's R6T, there's R6T plugged onto the thermistor. We can see it's on a common plug, plugged onto X33A. If my eyes can read there, okay, and we can see that it is the fourth thermistor on there. Okay, so it will also then give you an overview of where these thermistors are located inside the condenser. So you don't have to go and pull every single thermistor out. You can take this and basically find out where that thermistor is. All right, and then obviously typical thermistor checks, as I explained just now, you'll need a multimeter. Obviously you've identified it, and then you'll need the pressure, the temperature resistance characteristics of that. Okay. Where to find information and location of component inside. Okay, basically we've just seen that now. And just to quickly go over it, here's one on pressure transducer. Sorry, if I could just ask if you could just turn off your microphone. Okay. There you see the two pressure transducers, the low and the high pressure, the symbol. Okay. Again, where they plugged into on the PC board, X31 and X32A. Okay. And that's basically it. Now here's a little fact that you may not have known. Okay, when looking at a PC board and we ask you to test on certain pins, it's easy to find out what the pin numbers are if you see this little triangle or a 1. Okay, that designates that that end is pin number 1. Okay, and you'll see that they read off right to left. Okay, not as we read, left to right, but right to left. Okay, so you need to just keep that in mind, and that's just a little fact that's worth knowing as well. It'll save you many hours of trying to hunt something down. All right, I've gone through that, and now we're going to start looking at component testing. All right, and on the subject of component testing, it's quite important. Some basics that you need, that you must have. Okay, you must be able to use a multimeter. Okay, in the different functions, as in measuring voltage, resistance, and doing a diode check. All right. I also recommend that you have good quality equipment and that equipment is in working condition. All right. I've come across a number of guys that, and I know that money's tight, but the guys will buy a multimeter from Midas, and when we use them on site, we find that they give varying results over a number of tests compared to something that is of better quality. And also they tend to, the wires inside the testing leads tend to be harder and they tend to break, and then the guys start getting all sorts of crazy readings. Now remember that when you're measuring something, then you're using it for electrical work, you actually put in your life on the results that gives you. Because if you think that there's no power and you go disconnect something and you get shocked, it could be the end of you. So I do recommend that you guys look at the quality of your tools and make sure that they're in good working condition. A lot of misdiagnoses are made because of poor quality or poor performing measuring tools. And I think the same goes for your gauges as well. Okay, so I think we've all, if you've been in the industry for many years, I think you would have by once or twice or more been caught it out by something that was giving you the wrong reading and finding out that something it wasn't actually your unit to start with, it was your measuring device. All right, so if we look at where we're going with this, we're going to look at the inverter PC boards, we're going to look at fan motor testing, expansion valve testing, the thermistors, the pressure sensors, we'll look at in more depth, and then we'll just have a quick look at inverter compressor replacement as well. And then I'll just advise you of some documents that we've actually put together, which we can give to you, which will help you in terms of compressor replacement as well. Very, very important things to remember. Okay. So we're going to go into that, and we're going to note that the PC board is laid out, okay, in a way that for an inverter PC board. This is an inverter PC board for an inverter compressor, okay. And you can see over here that the diode mode is pack module is marked out in these red dots, and the power module is marked out by the blue area. Okay, so that when we test this over here, we're going to need to know what tests we need to carry out in order to determine which part of this PC board failed. Okay, so inverter PC boards are a power module device, okay, that takes three-phase power, okay, and converts it into a pulse width modulation output, okay. Basically, it converts it to a DC signal, and then takes that DC wave and causes it to look like a sine wave, okay. And then by playing with the frequency of that, okay, and a slight amplitude in it, it actually changes the speed of the compressor. Now, the only way that you can effectively change the speed of a motor is by playing with the frequency. And I think if you go back to the old days of standard compressors, many of you may have remembered that you could often select replacement compressors from Tecumseh and things like that, and you would see a chart for 50 and 60 hertz, and you often notice that, well, you would have noticed that a 60 hertz compressor had a slightly higher output due to its higher speed. Okay, so basically what this device is doing is we are playing with the input voltage, okay, the sine wave, the 50 hertz sine wave that we get from Eskom when they give it to us, okay, and we are converting that into a frequency modulated waveform, okay, that we can then vary the speed of the compressor with. Okay, so there you can see blocked out is our diode mode, and here is our power module, okay. And this is just a very basic schematic. If you guys want to get some more information on this, there's a site that is, I can actually give it to you, it's Engineering Mindset, okay. And if you go onto that site, the guys put together some very, very nice explanations of how certain things in air conditioning units and electrical items work. One of the things he covers is in depth is this principle over here. And he does it very, very nicely to actually show it in an animated form. And it definitely increased your knowledge by watching it. Okay. All right, now in order to test this, the inverter PC board, like I said, you will need to be able to do a diode module, diode mode, okay? And you will need to be able to identify certain components on the board to be able to go and test them. Now, I always tell the guys, and this is how I go about doing this, because you need to work in a methodical way, okay? If you look inside the service manual, it will give you a table, and it will give you a procedure to follow as you go through. Now, what I do is you can take this over here, okay, and you can just make your own little table if you want, or if you wanted to photostat it before you went to site, and basically you test each item methodically on that line, and you check it. Yes, yes, pass, no, it failed. Hang on, one failure in this, the PC board fails the test, okay? So you follow through that procedure, testing from P1 to J1, okay? And you can see that these items, I'll show you now, another way of going before you do the test is to identify the areas that you need to have. And you'll see that they are all diode checks, okay? But they have varying values, okay? And you're allowed a 10% discrepancy. in those over there. So basically, that's what the PC board looks like from the top. Okay, and when we zone in or we zoom in, we then mark out the different areas, and you then, what I would also recommend is if you've got a Kogi pen, mark them and then go about doing your testing according to that table. Okay, now these notes will be available, but all of this is available as well in the service manual, okay, for the particular units. All right, so that would be where you would test the item. Okay. And now, like I said to you, it must pass all of the tests. Okay, it's not a case that it must only pass 9 out of 10 or whatever. It must pass 10 out of 10 in order for the PC board to be good. All right. Okay, remembering with faulty inverter PC boards, it is very important that you don't only use your multimeter, okay, when testing the compressor. It is very important that you actually measure the compressor. Okay, and understanding how to use a measure is also a very big part of fault finding, especially with the compressor motors. A lot of guys will do a short pulse test. It's recommended that when you do your 1000-volt tests and all that on a motor, that you hold that down or you use the lock function on your measure and do at least a 3 to 5 minute test to see if there's any breakdown in the insulation. Okay, and we've seen results where guys will do just a simple pulse test, and when you hold the voltage down through the lock button on it, you will see the fault come to light when they're down to earth, where you'll see a winding that's shorted or something. Okay, very important, because if you take one of these PC boards and you fit it onto a faulty compressor, all right, okay, that is not a warranty claim. Okay, that is parts replacement, and the client pays for the first board, you pay for the second one. Okay, if you don't get the fault finding, so it's very important to remember that. All right, these are just some images to show you the layout on the PC board. Okay, just to give you an idea of where the different items are. These are also in the service manual as well to help you. Okay, so that's basically checking the inverter PC boards for the compressor. All right, if we look at the inverter fan motor, on VRV4, you'll notice that the inverter fan motor had 2 leads on it. It had a 3-wire lead and a 5-wire lead. Okay, on VRV4 Plus, that is now only a 3-wire lead. So this test applies to VRV4 and VRV4 Plus. Okay, and this is basically a standard motor test where you are measuring the windings on the motor. It's a 3-phase motor, therefore all windings must be equal. Okay, and the values differing depending on different motors are also given inside the service manual. All right. On VRV4, okay, you will also note that there was a 5-wire, and this plugged on. This was the feedback for the motor to the PC board. Okay, through Hall ICs. Okay, and in order to test that, what you would need to do is measure 1, 2, and 3 all to 5. Okay, and then 1, 2, and 3 all to 4. Okay, and that basically they must all be balanced within 20% of each other on them. Okay, and that's for the Hall IC. One further check to carry out when you have that 5-wire device, okay, is the following. Just to excuse this popping up on my screen. All right. You also need to check the way the Hall IC counts. Okay, so the first thing you do is you disconnect the X2A plug. Okay, with the power off, operation off. Then after disconnecting, you turn the power on and you measure the voltage between pins 4 and 5. That's the gray and the pink. And you'll be looking for 15 volts. Okay, then power off, connect X2A back onto the PC board. Okay, and then basically you'll put your leads across 1 and 5, and you will rotate the fan blade 1 turn. Okay, and in doing that, if the Hall IC is functional, you will see pulses, okay, 4 times from 0 to 5 volts as that fan motor goes through 1 revolution. All right, and you need to do that for terminals 1 to 5, 2 to 5, and 3 to 5. Okay, and this will determine if the Hall IC that's inside the motor is functioning. Now the Hall IC is counting and it's sending those pulses back to the PC board, so the PC board can then make a calculation on the number of RPM that the motor is doing, and then it will give that information back to the control board, and the control board will decide whether that RPM needs to be increased or decreased or held. Okay, and if it doesn't see any feedback, it then registers that it's been asking the motor to run, there's no feedback, something goes wrong, it will generate an alarm. Okay, right. Why is this frozen again? Right, there we go. Yeah, right. Okay, before we carry on with the expansion valves, I'm going to just ask, are there any questions out there? Okay, I'll take it there's no questions. Is everybody still with me?
Yes.
Okay, great, thank you. One of the most difficult things about training online is you have no idea if everybody is still with you. That you can see in a classroom. Okay, thanks very much for the response there. Okay, right, we're going to look at indoor expansion valve motors. Okay, these devices work by pulsing. They've got windings inside them. Okay, and if you look at this setup of windings that we've got on here, okay, you will see that the windings are all equal, but they are broken in the middle. So if you measure between white and red and orange, the resistance should be the same. If you measure between white and orange, it'll be the sum of the windings there through 1 and 3. Okay, and 2 and 4, the same on the other side. So when you check the check for it, you need to look on your pins. There are different pin layouts for the expansion valves. You need to identify where you're going to measuring. So in other words, this set, white, red, and orange, okay, white, red, and orange will be measured there. Yellow, brown, and blue across there. Yellow, brown, and blue on this, on one side, white, red, and orange. Yeah, sorry, get that right over here. White, red, and orange are there, and the others are on the opposite corner of there. Okay, so just being able to identify, because you're going to be using your multimeter, and you're going to be putting your pins into these plugs, so you need to have a look and make sure that you're measuring on the right pins over here. Okay, this is on a 2000 pulse expansion valve, and the type of thing that we could see here would be measuring 150 ohms on each of these and 300 ohms across the top. Okay, and again, within 10% tolerance, if you're not getting a reading on any of them, or the readings are out from that, then the expansion valve motor needs to be replaced. Okay, there's also a procedure in here for resetting of the old type indoor motors. Okay, I'm not going to run through the entire thing. It's not something that's done often, but it's worth. If you have a motor that needs to be reset, then this is the method that you go through. Okay, basically just be me reading off a PowerPoint presentation right now. It's something that you actually need to go to site with this document and actually work through in the steps. But one thing it does say, be very, very careful. Step 9 is essential. Okay, do not leave it out. Okay, also be very, very careful when resetting expansion valve motors, that they must be coupled to the expansion valve body. Okay, if you open up these motors and you overdrive them, believe me, it's a nightmare to get this pin to go back in. In fact, sometimes you end up having to buy a new expansion valve motor on there. Okay, if it's been overdriven. Okay, here we're looking at an outdoor expansion valve. Okay, so the first one over there was for the indoors, and this one over here, they told us this is a 46 ohm. Okay, over there, and you'll see here they've commented up, okay, the midpoints of the windings on there. So when you measure this now, okay, you will measure only from the gray wire. You'll see it's a 5-wire device, okay, and then you will measure back from your gray to the others to check your readings. All right, okay, and this is for these valves do 480 pulses, and it's a much bigger head. Okay, and you'll actually see in the condenser they have a plastic cap over them as well to protect them. One of the things that you must be very careful of with expansion valves is that they are sealed, that you don't get water flowing down between the expansion valve coil, okay, and the body of the expansion valve. This causes corrosion, and over time it affects the performance of the motor until eventually it will fail. Okay, so be very careful of that. Those plastic caps must be on at all times to protect from the elements getting into there. Okay, when replacing expansion valves, okay, it's very important. The components inside the valve body, okay, are delicate. They not all of them are metal. There are some plastic components in there. When welding on it, you must keep that valve cool. And here's a bath of water that the valve's been inverted into. Remember, we want to keep it cool, but we don't want to get water in the pipes. So be very careful of that as well when you're working or replacing expansion valves. Yeah, we spoke earlier on about thermistors, okay, and the first set of thermistors that we're going to talk about are those that are coupled, okay, and they do the air and heat exchanger. So these you will find either mounted in the air stream, okay, or they'll be mounted on the pipes. Okay, and these over here are 20 kilo ohm thermistors at 25 degrees Celsius, and they are the inverse at 20 degrees. And generally, we often find ourselves in this band over here, okay? So we know that 23 and 22 be pretty close together, so we can always get a good estimate with these type of, these 20 kilo ohm thermistors as to how accurate they are, because most times we will find ourselves in this area. But this is a table for it over here. And basically, if you don't have the app, this table is also very useful to help you determine what the resistance should be. All right. Okay, the second thermistor that we talked about was the discharge one. And you can see this has a much larger scale. Discharge pipes operate at much higher temperatures. For instance, if we just go back one over here, you'll see at 80 degrees Celsius, for instance, okay, which is down here. This thermistor is sitting on its limits. Okay. So we need a thermistor that can measure, because 80 degrees Celsius is not a bad temperature to have on a discharge pipe. All right, so let's see where this one works out. And at 80 degrees Celsius, this is a 25 kilo ohm. All right, now to test this one, obviously if the unit's not working, you're going to have a hard time getting to 80 degrees. Okay, so you need to read back again, and you look at the 25 degree area and the 20 degree area, and this will give you resistances of around 200 to around 249, or yeah, close to 250 kilo ohms on there. Okay, so and there's a chart for it as well. Okay, also please remember, when replacing thermistors, it is critical that you put the insulation that is put on them at the factory back on. Okay, I come across a lot of thermistors that have been replaced, and they are lying out, half measuring the piping and half measuring the air flowing through the unit. And of course, this is going to give a false reading back to the PC board. The insulation is on there for a reason, okay, and it does need to be replaced after you've replaced a thermistor. Okay. Inspection of pressure sensors. Okay, we spoke about this. You saw it earlier on. Okay, we're going to look back at this. This also gives you a table, okay, if you don't have the app, but just to give you a bit more idea of what the table looks like. Where you're supposed to be measuring, we said before, remember it had a power supply that went on to the number 4 pin, okay, on the X45 and X46, all right, and then we had a varying voltage, which was related back to the pressure. And of course, this can be picked up, and it's very important if you're going to use this graph that you remember, if you're looking at the low pressure sensor, that you measure the low pressure gradient. Use that. In other words, if you go to your multimeter and it gives you something like 1.5 volts DC, okay, remember this is a DC measurement, then you go up to here, okay, and you go across, and we find ourselves sitting out here at about, yeah, something like maybe 0.6 megapascals. Okay, that would be the pressure on the unit. So what would we need to do on here? You would obviously need to have your gauges connected to the unit. Okay, you need to make sure that your gauges are giving you an accurate pressure. Okay, I've seen many gauges that that are long past their sell-by date and need to be replaced. Okay, and then you would then relate that all back and check whether the voltage is in line with the correct pressure that you're reading. Okay, and like I said earlier on, faults in these of here would generally give you JA and JC alarms. Okay, all right, and that's pressure transducers. Basically, we said a device that converts pressure into a voltage signal. When it comes to replacing compressors, what I'm going to tell you now is this is just a very quick overview. There's a couple of steps in here that have been left out, but it's just there just to get you going. We have put together a document, okay, which is available, and the document will take you through everything that you need to take into account and do when replacing a compressor. All right, and that will even come down to fitting suction core dryers, okay, and how to size the correct core dryers as well, and reminding you that you need to replace those as the system is being cleaned up after you have replaced a compressor. All right, so basically recovery of refrigerant is a very, very important thing, okay, and I'm going to cover it again in the last session. Okay, we're just going to go through it quickly. One of the things that you'll then do is you'll remove the sound insulation and power terminals from the compressor, cut the pipes